Hello and welcome back to the good stuff that we have been doing. Today in this video we're going to investigate the general formula for the integral representation of the polylogarithms, and this is how we define the polylogarithms. We define them to be the sum as n runs from 1 to infinity of x to the n over n to the a. For example, now the dilogarithm is defined to be equals to the sum as n runs from 1 to infinity of x to the n over n squared, and the trilogarithm is defined to be the sum as n runs from 1 to infinity of x to the n over n cubed. Now this is the dilogarithm, trilogarithm, and the pattern continues in that way. Of course, for the first case where we have a 1, that is a monologarithm, is just basically negative times the sum as n runs from 1 to infinity of x to the n. Sorry, not even negative, but a positive sign here. So of x to the n over n, which is negative times the logarithm of 1 minus x. So even the logarithmic function is actually a class of the polylogarithms. But now we're going to, this is their sum representation. We're going to derive the most important formulas, which is the integral representation, because for the theory of definite integrals, there are many classes of complicated integrals. The only way to actually solve such problems is to use the integral representation of the polylogarithms, and this is what makes these polylogarithms very, very important. This formula very, very important for our work. So how do we do that? Well, we're going to start straight up from the definition of the polylogarithm. So we're going to come here and say, okay, the polylogarithm here is defined. Okay, this is a mistake. The polylogarithm here of x is defined to be the sum as n runs from 1 to infinity of x to the n over n to the a. Now observe that in the theory of definite integrals, the gamma function, we have the integral representation 1 over n to the a is equals to 1 over gamma of a times the integral from 0 to infinity of you have t to the a minus 1 e to the negative nt dt. So this is the integral representation of the gamma function. So we could swap this and say this is the sum as n runs from 1 to infinity of x to the n. Now instead of 1 over n to the a, you would have the 1 over gamma of a times the integral from 0 to infinity of what? T to the a minus 1 e to the negative nt dt. Now this is where things get exciting, because in the next line we're going to have to bring out some things out of this integral sign. So what we'll do first of all is that we're going to write this as 1 over gamma of a. Then you would have the integral from 0 to infinity of t to the a minus 1, and then you would have the sum as n runs from 1 to infinity of x to the n, then e to the negative nt, and then you will have dt. Okay, now let's evaluate this sum first. So this would be 1 over gamma of a times the integral from 0 to infinity of t to the a minus 1. Now for the inner sum, we could just write this as the sum as n runs from 1 to infinity of x e to the negative t to the n power, then you would have dt. Now this reminds us of the geometric series, that the sum as n runs from 1 to infinity of x to the n is basically x over 1 minus x, whereby x is strictly less than 1. And this obviously is strictly less than 1 because of the factor of e to the negative t involved here. So we're going to move further, and then okay, so yes, so next what we'll do here is that we're going to write this as 1 over gamma of a times the integral from 0 to infinity of t to the a minus 1. Then I'll write in black, this is going to be equals to x e to the negative t all divided by 1 minus x e to the negative t dt. So now we have a beautiful integral in terms of our, this whole integral, keep in mind, is equals to the polylogarithm of a of x, but we need to simplify this integral. We can't just leave it this way. So to do that, we are going to write this as 1 over gamma of a, so times the integral from 0 to infinity. Now we will combine everything, so you have t to the a minus 1 x e to the negative t, all divided by 1 minus x e to the negative t dt. Now here you take y to be e to the negative t, whereby dy would be negative e to the negative t dx, dt rather, dt. So in this case, negative t would be log y, and whereby y, t would be negative log y rather. So in this case, t to the a minus 1 would be equal to negative 1 to the a minus 1 times the logarithm to the a minus 1 of y. So, and then x, okay, x cannot be touched, so that one does not concern x. So basically, let me bring this over here so you can see. Oops. No, let it be here. Okay, so basically you would have this to be equals to 1 over gamma of a. Now observe that since we let y to be e to the negative t, as t becomes 0, y will be 1, so you have the integral from 1. Now t becomes infinity, y will be 0, so you have the integral from 1 to 0 of the negative 1 to the a minus 1 logarithm to the a minus 1 of y. Then you would have an x, and you have negative dy, all divided by 1 minus x y. And things are becoming a bit more interesting now, because we can write this as negative 1 to the a minus 1 all divided by gamma of a. Then you would have the integral from 0 to 1 of x logarithm to the a minus 1 of y, rather, this is y, of y, all divided by 1 minus x y dy. And this is a beautiful integral representation of the polylogarithms. And point being that, for example, if you take a to be 1, you when a is 1, does it work? Okay, when a is 1, you will have the monologarithm of 1 of x to be equals to, this will be 0, so 1 minus 1 is 0, so this will be just 1 times equals integral from 0 to 1 of just the logarithm vanish. You have x over 1 minus x y dy, and this is actually equal to negative logarithm of 1 minus x, and that is the truth, because the logarithm of 1 minus x actually is equals to negative times integral from 0 to 1 of x over 1 minus x y dy. So now when a equals to 2, what you would have is that the logarithm of y, the logarithm of x rather, is equals to the integral. Now when a is 2, you have a negative sign here, so you have the 0 to 1 of negative x log y all divided by 1 minus x y dy. And even for the trilogarithm case, trilogarithm of x is going to be, in this case, when a is 3, you have 1 over 2, you have 1 over 2 times the integral from 0 to 1 of x log squared y all divided by 1 minus x y dy. And these formulas for the dilogarithm, trilogarithm, tetralogarithms are extremely important, and we shall soon see, as we make more and more videos on this channel, we're going to feature all these difficult integrals, as well as the application of these formulas to solve this integral. So thank you very much for watching, and please do subscribe to the channel. Bye, and have a nice day.